Bigger AI prompts are actually making your agents dumber, and Red Hat just proved it with hard data.
Wait, so cramming everything into one mega prompt is hurting performance? So we're breaking down the benchmark results, the trade-offs, and when to use each approach?
By minute 4, you'll know exactly which prompting strategy fits your use case. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today we're diving into prompt engineering, big versus small prompts for AI agents.
Stick around to the end for today's headlines. Let's dive right in.
So let's get into the technical details of how this actually works. Red Hat's implementation uses LangGraph for both approaches, but in very different ways. With the big prompt, LangGraph is basically just managing the conversation history. It's a glorified append operation. Every time the user says something, it gets added to the history and the whole thing gets sent to the model with that massive prompt.
And I'm guessing that prompt has to cover every possible scenario the agent might encounter?
Exactly. If you look at their lg-prompt-big.yaml file, it's over 2,000 tokens just for the base prompt, not counting any conversation history. It's got sections for understanding user intent, handling different types of laptop requests, managing approval workflows, integration with ServiceNow, everything.
That's a lot of cognitive load for the model to handle on every single request.
Right, and here's where the numbers get interesting. In their benchmarks, the big prompt approach averaged about 4,000 tokens per request once you factor in a typical conversation history. At current GPT-4 pricing, that's roughly 12 cents per interaction. Doesn't sound like much until you multiply it by thousands of IT requests.
Okay, so walk me through how the small prompt approach differs.
So with the small prompt approach, they've broken down the laptop refresh process into discrete steps. There's a prompt for initial intent classification. That's only about 200 tokens. Then there's a separate prompt for collecting laptop specifications, another for handling approval workflows, one for address verification, and so on. Each prompt is hyper-focused on its specific task.
And LangGraph is orchestrating all of these?
Exactly. LangGraph maintains the state machine and decides which prompt to use based on where you are in the workflow. The clever part is how they handle context. Instead of sending the full conversation history, they extract just the relevant information for each step. So when you're at the address verification step, the prompt only gets the user's previously provided address information, not their laptop preferences or approval status.
How did they determine what's relevant?
They use a combination of explicit state tracking and semantic filtering. Each step in the workflow has defined inputs and outputs. When the model responds, LangGraph extracts the structured data, like laptop model, memory requirements, shipping address, and stores it in the state. Then each subsequent prompt only gets the state variables it needs.
But doesn't that create potential for information loss? What if something from earlier in the conversation becomes relevant later?
Great question, and that's actually one of the trade-offs they had to navigate. They handle this with what they call context bridges. Certain critical information gets carried forward through the entire workflow, things like user identity, request ID, and any special requirements. But they're very selective about what makes it into these bridges.
So what kind of performance differences are we talking about?
The numbers are pretty compelling. With the small prompt approach, average token usage dropped to about 2,400 per complete interaction. That's a 40% reduction. But here's what's really interesting. Accuracy actually improved by about 15% on their evaluation benchmarks.
Wait, it got more accurate with less context?
Yeah, and this goes back to what we were talking about earlier. When you give a model a focused task with just the relevant context, it tends to perform better. They found that the big prompt approach would sometimes get confused and start mixing up information from different parts of the conversation. Like it might reference laptop specs when it was supposed to be collecting shipping information.
That's fascinating. So it's not just about cost, it's about performance too.
Exactly. And there's another benefit they discovered, debugging and iteration. With the small prompt approach, if the agent is struggling with a particular step, you can tweak just that specific prompt without affecting the rest of the workflow. With the big prompt, any change potentially impacts every interaction.
But I imagine the small prompt approach is harder to implement initially?
Definitely. Red Hat's team said it took about 3 times longer to develop the small prompt version. You need to carefully design your state machine, figure out the context bridges, test all the transitions. It's a much more complex system architecture.
So when would you actually choose one over the other?
That's the million-dollar question. From their experience, the big prompt works great for simpler workflows or when you're prototyping. If you need to get something up and running quickly, or if your workflow is relatively linear without many branches, the big prompt is hard to beat. But once you hit a certain scale, they found the tipping point was around 500 requests per day, the cost savings and performance improvements of the small prompt approach become compelling. Stick around, we'll give you the exact decision framework they developed. All right, so let's talk about how you actually make this decision in practice. Red Hat developed a really useful framework for choosing between big and small prompts, and I think it's worth walking through.
Yeah, because I imagine a lot of teams are facing this exact choice right now.
First factor is workflow complexity. If your agent needs to handle multiple branching paths, like their laptop refresh example where users might need approvals or might be eligible for different laptop tiers, the small prompt approach starts to make more sense. They found that once you have more than 5 distinct decision points in your workflow, the big prompt becomes unwieldy.
Makes sense. What about scale considerations?
This is where it gets really practical. They created the simple calculation. Take your expected daily request volume, multiply by your average conversation length in turns, multiply by your token cost. If that number exceeds $50 per day, you should seriously consider the small prompt approach. For their laptop refresh use case, they hit that threshold at around 500 requests per day.
That's a really concrete metric. What about development resources?
This is crucial. The small prompt approach requires about 3x the initial development time and significantly more expertise. You need engineers who understand state machines, can design good abstractions, and can debug complex multi-step workflows. If you're a small team just trying to automate a simple process, the big prompt might be the way to go.
What about maintenance and iteration?
This is where small prompts really shine. Red Hat found that once the initial system was built, making changes to individual steps was much easier with the small prompt approach. They could A/B test different prompts for specific steps without affecting the entire workflow. With the big prompt, every change is a potential breaking change for the entire system.
But doesn't that modularity come with its own risks? Like, what if the prompts drift apart over time?
Absolutely. And that's why they implemented what they call prompt contracts, essentially interfaces that define what each prompt expects as input and what it should output. They also have a comprehensive testing framework that validates these contracts. It's more work up front, but it prevents the kind of drift you're talking about.
So what's the actual implementation path if someone wants to try this?
Red Hat's recommendation is to start with the big prompt for prototyping. Get your workflow working end-to-end, understand your users' needs, identify the pain points. Then, once you have a stable workflow, you can refactor to the small prompt approach if the scale justifies it.
That seems pragmatic. Start simple, optimize when needed.
Exactly. And they've open sourced some tools to help with the transition. They have a prompt analyzer that can look at your big prompt and suggest how to break it down into smaller components. It's not perfect, but it gives you a starting point.
What about hybrid approaches? Could you use big prompts for some parts and small prompts for others?
Now you're thinking like an architect. That's exactly what some teams are doing. They use small, focused prompts for well-defined steps like data collection or validation, but then use larger prompts for more creative or open-ended tasks. It's not an all-or-nothing decision.
That makes a lot of sense. Use the right tool for each part of the job.
And here's something that I think is really important. This whole debate is really about the maturation of AI engineering as a discipline. We're moving past the wow, it works phase and into the how do we make this reliable, cost-effective, and maintainable?
It's like the evolution we saw with web development, right? First, it was just getting something on the screen. Then it was about performance, scalability, maintainability.
Exactly. And I think we're going to see more patterns like this emerge. The prompt engineering of 2025 is going to look very different from what we were doing in 2023. It's becoming a proper engineering discipline with its own best practices, design patterns, and trade-offs.
So what should teams be doing right now to prepare for this?
3 things. First, start measuring your token usage and costs now, even if they seem manageable. You need baseline data. Second, document your prompts and workflows obsessively. You'll thank yourself later when you need to refactor. And third, invest in testing infrastructure. Whether you go big or small, you need to know your agents are behaving consistently.
That's really practical advice.
And here's my final thought on this. The big versus small prompt debate isn't really about the prompts themselves. It's about understanding your constraints and optimizing for what matters most to your organization. Sometimes that's development speed, sometimes that's runtime cost, sometimes that's accuracy. The best engineers will be the ones who can make that trade-off intelligently. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from AWS and Hugging Face. They've released a detailed guide on building agentic AI systems using Hugging Face's small agents framework on AWS infrastructure. This is particularly interesting because they're showcasing a healthcare AI agent that uses multi-model deployment.
Healthcare AI agents? That sounds like it could be really powerful. What makes this approach special?
What's clever here is how they're combining vector-enhanced knowledge retrieval with the agent framework. The system can pull from multiple models and knowledge bases to make more informed decisions. AWS published this on their machine learning blog, and it's getting attention from developers who want to build more sophisticated AI agents.
Speaking of visualizing AI, have you seen this incredible MicroGPT visualizer that's making rounds on Reddit? Someone took Karpathy's MicroGPT project and created an interactive website that shows the entire process from tokenization to inference.
Oh, the one that generates Korean first names? That's such a creative twist on the original project.
Right. Users can actually explore each step of how the transformer works. It's educational content done right, making complex AI concepts accessible through visualization.
Now, shifting to enterprise news, OpenAI just announced their Frontier Alliance partners, and the list reads like a who's who of consulting giants: BCG, McKinsey, Accenture, and Capgemini.
That's quite the lineup. What exactly are these partnerships about?
They're positioning these firms to help enterprises deploy and manage AI coworkers built on OpenAI's Frontier platform. It signals a major push into enterprise AI deployment, with these consulting firms essentially becoming the implementation arm for OpenAI's technology.
And speaking of enterprise implications, we have some serious news from TechCrunch. Defense Secretary Pete Hegseth has summoned Anthropic CEO Dario Amodei over the military's use of Claude.
The Pentagon is actually threatening to designate Anthropic as a supply chain risk. That's pretty unprecedented for an AI company.
This could set a major precedent for how AI companies interact with defense departments. The tension between commercial AI development and military applications is really coming to a head here.
On the software release front, LiteLTM just dropped version 1.81.14, and it's marked as a security release. Berry AI has been busy. They've added AI-powered duplicate issue detection instead of just matching title text.
That's actually pretty clever, using AI to manage AI development issues. What else is in this release?
They've split their CI test matrix to speed up build times, added Vite test unit tests for the UI components, and replaced their Zapier webhook with a dedicated feedback endpoint. Plus, there's a new retry count feature in the logs, which developers will appreciate for debugging failed requests.
Solid improvements across the board: security, performance, and developer experience.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who would appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.